TNA, and welcome to Lesson 5 of your energy topic for your GCSE level science. So, today we're talking about specific heat capacity. As is normal for every other lesson, make sure that you have everything you need for this lesson. So you have your booklet or your paper that you're going to be making your notes on, you have your regular color pen, whether that be blue or black, you have your feedback color pen, whichever color that may be. Again, for this lesson, you will need a calculator. If you are using your phone as a calculator, make sure that you do put it into do not disturb mode so you can focus in on the lesson, and make sure as well that if you are not using your phone as a calculator, that you put your phone completely away so you can focus on the lesson for the time that you need to. So without further ado, in your books or on your paper, I want you to answer these 8 questions for your do now. Pause the video, write in the answers, and we'll be back in a moment with the answers. So here are the correct answers for your knowledge check. Make sure that for question 1 and 2, you do know what all those letters are. So kinetic energy is equal to 1/2 times mass times speed squared, and gravitational potential energy is equal to mass times g times height. Remembering that g is the gravitational field strength, which is measured in newtons per kilogram. So today, as I said, we're looking at specific heat capacity, and it refers to how different materials need different temperatures. So if you have ever been to the seaside in the summertime, the sand, you might notice, can be a lot hotter than the water. All right? You might think they should be at the same temperature as the air, but remember that the heat is coming from the sun, and different objects need different amounts of heat to heat up all the way. All right, unfortunately we can't do these demonstrations here. If you would like to see a video that covers some of these things, here's a video here you can type into and have a look at. I will also try to link it in the description below so that you have a chance to click on it and go watch that video. But go watch this video and think about, why does the balloon not pop? I want you to write the answer to that in your books. So as you've watched that video, you should see the balloon does not pop because of the fact that there's water in there, and that water has a higher specific heat capacity than the water, or than the balloon. What will affect how quickly something heats up is both the mass of that thing and as well as the material it's made from. So these two things, so the mass and the material it's made from, will affect how quickly something heats up. Okay? So if we have more mass, so if we have more water, it will take faster to heat up. For example, if you put a lot of water in the kettle, it will take longer to boil than if you only have a little bit of water in the kettle. It also makes a difference as to what it is you are heating up. So for example, heating up oil actually happens a lot faster than heating up water. So that is because of the specific heat capacity of that thing. Right? So increasing the mass of a material affects the amount of energy required to raise the temperature by 1 degrees Celsius. So that is how we measure that energy, how much energy it takes to raise the temperature by 1 degree Celsius. And this is because there's more molecules. So if we have more mass, there's more molecules to share that energy. So for example, if you have a mug full of water in the kettle, each molecule gets more of the energy every second than if you fill the kettle right full, right? Oil and water need different amounts of energy because they have different levels of specific heat capacity. They just take more or less energy to heat up. So here's the definition for specific heat capacity. This is one you need to know, so write it down now. So the specific heat capacity of a substance is the amount of energy required to raise the temperature of 1 kilogram by 1 degree Celsius. All right, we know the energy is measured in joules. So the specific heat capacity works with joules as well. Specific heat capacity is joules per kilogram degree Celsius. So we'll have more of a look at that on the next page. So make sure you have that definition written down, and we'll come back to it a couple times. So here is the equation that we can use to calculate how much energy it takes to heat something up. So the change in thermal energy is equal to the mass times the specific heat capacity times the temperature change. So in science, we like to use our Greek letters. So here we use the Greek letter delta, which is represented by a triangle. So the change in thermal energy, so we have our change in energy, so delta E stands for the change in thermal energy. Mass, we know, is an M. Specific heat capacity is the C. And then the change in temperature is this symbol here. Is change, again, we have the delta, we have the change in, and the theta, which represents temperature. All right, because we've run out of letters, we need to start using the Greek letters. So I want you to write down this equation, both in words and in symbols, into your books, and think about, what do we measure all of these things in? What is the scientific unit that we use to measure energy, mass, and temperature? So hopefully you remember that our change in energy is measured in joules. Our mass is measured in kilograms. And temperature we measure in degrees Celsius. So that is what we have. We have change of energy, which is measured in joules. We have our mass. We have our specific heat capacity. This is one that I need you to add in now, is again joules per kilogram degrees Celsius. And we have our change in temperature, which is degrees Celsius. Sometimes the change can throw students off. So when in science we're talking about a change in something, so change, we always just look at the fact that it's the first, so the starting temperature, subtract the ending temperature. Or the change in thermal energy, it's the starting energy, subtract the ending energy. All right, now that we've done that, pause the video, look at your book, and just write, without looking back, see if you can write down the equation for specific heat capacity, including having all of the units that you need. So switching now to your feedback colors, hopefully that you were able to do this without looking back, but we have our change in energy, which is equal to our mass times our specific heat capacity times our change in temperature. All right, the SI units, remember, are just the scientific units. So this is in joules, mass is in kilograms, change in temperature, degrees Celsius. Our specific heat capacity is joules per kilogram, degrees Celsius. So now we just need to, same as the last several lessons, plug some numbers into the equation. So this is our example that we can do. So how much energy is needed to increase the temperature of 600 grams of water by 80 degrees Celsius in a saucepan? So as we read that, we go through and we look at what we know. We have 600 grams of water. You should remember that we can't use grams in an equation. We need to change it to kilograms. So they've already worked that out for us so nicely. So 600 grams is 0.6 kilograms. So we know that. Our change in temperature is 80 degrees because we're increasing by 80 degrees. So we know that that's our change in temperature. So that is our change in temperature. And they don't give us this here. And sometimes you have to look somewhere other than the question, but the specific heat capacity is 4,200 joules per kilogram degree Celsius for water. If we're looking for oil, it would be different. If we were looking for a metal, it would be different. So our first step, we've done that. We've looked to see what we have. And then we look to see what we need, how much energy. So our energy is what we're looking for. Next, we write out the equation. Our change in energy equals mass times specific heat capacity times change in temperature. We plug in the numbers, and then we write it down with the unit. Remember, no unit, no mark. All right, so if you need to rearrange it, I wouldn't recommend memorizing all of those, but rearrange it in the question itself. All right, so we'll have lots of practice with that, but it works the same way as it does for any other thing. All right, so remember when I told you to memorize specific heat capacity? I want you to write down the definition without looking back of specific heat capacity in your books. Swapping now to your feedback color pen. So definition for specific heat capacity, we have how much energy it takes to raise the temperature of 1 kilogram of a substance by 1 degree Celsius. So that is our definition of specific heat capacity, how much energy it takes to raise the temperature of 1 kilogram of a substance by 1 degree Celsius. Make sure you have that written in, and we'll get on with the maths. So here we have a table showing the specific heat capacities of several different things. It will make it easier to continue the questions if you have that table written down. So I want you to pause the video and just write down the specific heat capacities for these substances into your book. So water, oil, aluminum, iron, copper, lead, and concrete. Pause the video and go ahead. So now I'd like you to look at these 3 questions here and use the information in the table to help you explain the statements. So we'll do the first one together, and then I want you to pause the video and try the second 2 on your own. So a mass of lead heats up more easily than the same mass of aluminum. So if we're talking about how easily something heats up, we're essentially saying how much energy does it need? So it's a case of how much energy and if we're talking about how much energy something needs to heat up, we know we're talking about specific heat capacity. So we're going to look at our table, or the numbers you have written down, and we're going to look to see lead, our specific heat capacity of lead, equals 130 joules per kilogram degree Celsius. Whereas our aluminum, it's 900 joules per kilogram degree Celsius. So we see that lead has a much lower specific heat capacity than the aluminum. And so that's just what we need to explain it. So because lead has a lower specific heat capacity than aluminum, it takes less energy to heat it up. I'm going to be more specific, because the more specific you can be, the more likely you are to get all the marks. Heat it up by 1 degree Celsius. So it is easier to heat up. So that's all it's asking for. It wants you to refer back to the specific heat capacity to explain why that is. So looking at question 2 and 3, pause the video, give them a go, and we'll come back for your green pens. So here are those green pen answers for those questions. So question 2, it's pretty well the same as question 1, just with different substances and in reverse. So why is it less easy to heat up? And the third one, you have to think about it a little bit more, but looking into the definition of our specific heat capacity. And because metals have a lower specific heat capacity than water, the temperature of it will heat up more with the same amount of energy. So it takes less energy to heat metals than water, so they will heat up more with the same amount of energy. So now we're going to start looking at some questions. So again, this is why we have that table written down, so you don't need to keep referring back up. So for all of these questions, how much energy is needed? So we should write that down for all of these questions, because that's something we know. We know we're looking for the energy without it being directly in the question there. So we know our change in energy is our unknown. 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 So we know that. All right. And then we need to look at those specific we need to look at each question individually after that. So for question 4, how much energy is needed to raise the temperature of 2 kilograms of water by 30 degrees Celsius? So we know we have 2 kilograms and we know we have 30 degrees Celsius. So our mass is 2 kilograms. Our change in temperature is 30 degrees Celsius. And we refer back to the table we've written down. Aluminum, our specific heat capacity is 900. So our specific heat capacity is 900 joules per kilogram degrees Celsius. Oh, that's in the wrong spot. Specific heat capacity is 900. So we have that there. So we know what we have, we know what we don't have. Our next step is to write down the equation. Remember, you can always get a mark for writing down the proper equation, so making sure you just always write it down. So our change in energy is equal to our mass times our specific heat capacity times our change in temperature. So our change in energy is what we don't know, so we're going to leave that be. Our mass we know is 2 kilograms. Our specific heat capacity is 900. And our change in temperature is 30 degrees Celsius, right? Because we're raising the temperature, and that's why it's a change. So raising the temperature. Next, we just plug that into our calculators. So we have our 2 times 900 times 30. And our final answer, helps if I switch to my pen, our change in energy is equal to 5,000 or 54,000. What am I missing? That's right, I'm missing my units. Our change in energy is measured in joules. So it takes 54,000 joules of energy to raise the temperature of 2 kilograms of aluminum by 30 degrees Celsius. So now I'd like you to give a go to question 5, 6, and 7. And then we'll come back for the feedback color. So here I have the answer to question 5. We have our mass. Here you had to calculate the change in temperature. So we go from 20 to 60. And as I said in the beginning, that the change is the ending, take away the starting. So we end at 60, so 60 take away 20 is 40 degrees Celsius. So we plug 0.05, 40 degrees Celsius, and our specific heat capacity of 4,200 into our formula. We end up with 8,400 joules. Remember, no unit, no mark, so don't forget to add the joules. All right, if you struggled with the other two, pause the video and go back to them now. Otherwise, there are the answers to question 5 and 6 as well. Any questions about those, make sure you do email your teacher for that. So here we have some more calculations. All right. Some of these might include some rearranging. So we'll do the first one together. And then after that, I'll pause the video. I want you to pause the video and go through and work on them on your own. So the first one, specific heat capacity values can be found in the table above. So we know that we can look at that table that you've written down in your books. So the temperature change of 100 kilograms of water. So we know that this is our mass. In a solar heating system is applied with 100 joules. So this is our change in energy. We're looking for the temperature change. So that is what we don't know. And we know it's water. So we know our specific heat capacity from the table is 4,200 joules per kilogram degree Celsius. So with all of that, we can just go in and plug that into our formula. So we have our change in energy is equal to mass times our specific heat capacity times our change in temperature. So we plug in the values that we know. So we know our change in energy is 100 joules. We know our mass is 100 kilograms. We know our specific heat capacity, 4,200. We do not know our change in temperature. So we're leaving that as it is. And now it's just a maths problem. So in order to get our change in temperature by itself, since we're multiplying here and multiplying here, we can divide by either side. So 100 divided by 100 divided by 4,200 is equal to our change in temperature. So we plug that into our calculator. And we end up with a very, very small number. So we end up with 0.00023 degrees Celsius. All right, because remember, no units, no marks. So for the rest of these, it's again, the hard step here is just going and rearranging the equation. So however you feel comfortable doing that, you can do that, but make sure you do make that step visible because this is now a 4-mark question. So we have, for our number of marks, we have 1 for writing down the formula, 1 for plugging in the numbers, 1 for rearranging it, and 1 for the final answer with units. So it is an extra step, but you can easily do it. So looking at these next 3 questions, giving them a go. We'll come back with our feedback color in a moment. So here we have the answers to those 3 questions. Make sure you do have all the steps written down. It is a really good idea to go through the question and make sure that you know all the bits before you start it so that you know what you need to find out. So for the first question here, we have the mass of iron that experiences a 10-degree temperature change if it receives 1,000 joules of energy. So we know our change of energy, we don't know our mass, we know our specific heat capacity, and we know our change in temperature. Our specific heat capacity, remember, comes from that table that we had earlier. So then we were multiplying, so we just need to divide the opposite. So 1,000 divided by 490 divided by 10 gives us our mass of 0.2 kilograms. Remember, no units, no marks. Next question is asking for the specific heat capacity. So it's the same steps, it's just we have a different thing that we don't know. So plug in our numbers, write down a formula, plug in the numbers, rearrange, plug it into the calculator. We end up with a specific heat capacity of 500 joules per kilogram degree Celsius. Remember, no units, no marks. The one extra step you did have to do here was you had to convert to joules. Remember, there's 1,000 joules in a kilojoules, same way there's 1,000 grams in a kilogram, 1,000 anything in a kilo anything. And so the specific heat capacity of copper, again, you're looking for your specific heat capacity. So we know our change in energy, we know our mass, we know our temperature. It's the same thing. Just plug the numbers into the formulas. So here we have a knowledge check, going through, giving them a go. Question 6 and 7 looks like it might need a calculation, so have your calculator ready, and then coming back for the answers. So here are the answers to the knowledge check. We have our units. Remember, if it asks for units, it asks for the SI unit. So you couldn't do temperature change in degrees Fahrenheit or degrees Kelvin because we're looking for those scientific units. All right. Question 6, by how much energy would it need to raise the temperature of 2 kilograms of copper compared to 1 kilogram of copper? Because the mass is doubling, the energy is doubling, so we just need twice as much. And which one has a higher specific heat capacity, or lower? The lower one will heat up faster for question 7, and that's why it's the sand. Any questions about anything in this lesson, make sure that you email your teacher to ask. Don't forget to do any follow-up tasks your teacher has set, whether that be an Educate quiz or anything else. And we'll see you again for the next lesson.